Here's another visible satellite loop of New York State taken on July 31st, 2017. A lot of different things to look at once again. The first thing I wanted to point out, I think we've mentioned in previous videos, is the fog that was forming in the valleys overnight. And as the sun rose, you can see the first few frames that fog dissipates. As the temperature rises above the dew point, you get evaporation and the fog disappears. The condensation will turn back into water vapor, invisible water vapor in the atmosphere. After that fog dissipates, you'll see that the ground heats up enough that you start getting this popcorn appearance, these cumulus clouds that are forming as bubbles of warm air rise up off the ground as the ground heats up with the strong July sun. And you will also see around Lake Ontario here some interesting cloud formations, some lake breezes forming, not classified as sea breezes because they're coming off the lake, but you can see that there's a relatively clear area around the southern shore and eastern shore of Lake Ontario, free from those popcorn cumulus forming. Relatively cool, stable air moves in from the water, preventing air from rising. But further inland, you do get that rising air as it's not under the influence of the marine environment from the lakes. You can also see you have a clashing of sea breezes on the western side of Lake Ontario. You've got air that's pushing inland around the Niagara Falls area, but you also have something similar happening with Lake Erie pushing northward, and where these two lake breezes meet up with each other, you'll see there's an enhanced area, enhanced band of cloudiness that develops right over Ontario and western New York. Another feature I want you to take a look at is this thunderstorm complex that was moving out of southern Ontario overnight. Not necessarily the complex itself, but you can see some of the cirrus blowing off as the top of this storm reaches the tropopause. It can't go any higher, so the upper level winds blow the cirrus off. But what's going on behind it? As the air rains down through the atmosphere, it cools the atmosphere, evaporational cooling. And because you have a relatively cool atmosphere behind it, you're not seeing a lot of clouds. Remember, in order to get clouds to form, you need rising motions. Rising motions require low density air. Low density air is warm air. So you have relatively high density cool air behind the storm, and you can see it's a relatively cloud-free area that develops behind the storm with much greater cloud cover outside of where that storm hit earlier in the day. Here's a radar loop of the same region at the same amount of time. Here's that cell or series of cells that was moving out of Ontario with this cold, stable air behind it. You can see how you got that gust front moving out in front of it, which is like a little mini cold front. You get the rising motions as indicated by the reds and oranges. That's where the heaviest precipitation is, and just ahead of that you would probably see the greatest rising motions associated with the storm. So very strong rising motions in these areas here, and you can see along the flanks as that cool air spills out in all directions, new storms are firing up on either side of it, because they act again like little mini cold fronts, pushing the warming air during the afternoon higher and higher. You can also see down here in the southern tier where we had those popcorn cumulus clouds forming, you're actually starting to see a couple radar echoes indicating that there is some rain falling out of those clouds. They've become big enough, tall enough that you're starting to get rain droplets large enough to actually bounce the radar back to it, indicating that there is probably rain at least falling within the cloud. Maybe not any rain falling down to the surface at this point. You need to saturate the air underneath the cloud in order to get the rain to fall away to the surface, or close to saturated anyway. So a lot of this rain is probably evaporating before it hits the ground. You can also see over here there's a weak cold front that's moving down through Canada, and there's some other showers that are firing up ahead of it, the cold front. But this is the main action associated with the larger cold front. You can see some smaller little mini cold fronts and gust fronts associated with it.